In this video, we're going to talk about a more convenient way to draw Lewis structures that we call line structures. So on this page, you can see two drawings. One is a Lewis structure representing caffeine, and the other one is a line structure representing the same molecule, caffeine. Now, in organic chemistry, carbons and hydrogens are very abundant in most molecules. So we've got basically a shorthand way to represent them in a structure without actually having to write them out every time. Carbons will always be represented in a line structure just by an angle or a point. And we know that carbon likes to form four bonds. So we'll show all other atoms that are not hydrogen that are bonded to the carbons. However, the hydrogens aren't shown, but we can know how many are there just by our knowledge of carbon and the fact that it likes to form four bonds and what else we see connected to that point. So let's just start right here on the molecule. You can see carbon, three hydrogens bonded to it, and a nitrogen, satisfying its need to form four bonds. In the line structure, you can see just a line coming off the nitrogen. And this point right here represents that carbon. Since we can only observe one bond to something that's not hydrogen, we can therefore imply that there are three hydrogen atoms bonded to this carbon, again, satisfying its need to form four bonds. Over here, you can see a point, and that represents a carbon atom, but you can see four bonds coming off of it. So therefore, that carbon doesn't have any hydrogens, and when we look over at the other structure, we can see that that's the case over here. That also holds true for almost all of the other carbon atoms in this molecule, as they already have four bonds without even incorporating a bond to hydrogen. There's three more exceptions to that. This carbon right here and this carbon right here are just like that first carbon we described. We can only see a bond to one other atom. Therefore, each of those carbon atoms have three hydrogens bonded to them, satisfying carbon's need for four. But if we look over here at this point, you can see that there are three bonds shown connecting to that point. Therefore, this carbon atom needs one more hydrogen to be satisfied. And you can see it's not shown here in the line structure, however, it's shown in the Lewis structure. So again, this is basically just a shorthand way of drawing out a Lewis structure, which is very convenient when we're drawing much larger molecules. Let's try one more and see how we do. This right here is histidine, an amino acid, and you can see that the carbons aren't shown and none of the hydrogens, except for those connected to other functional groups, such as right here and on the nitrogens. This carbon right here, this point, shows three bonds coming off of it. Therefore, we can say that it needs to form one more bond, and that would be to the unshown hydrogen. And that's actually represented right here in the structure down below. I know they're not arranged the same way, but that's the carbon atom I'm describing right there. Now, if we come over here, this carbon atom, you can see four bonds coming off of it. Therefore, it doesn't need any hydrogens, and you can see that in the Lewis structure, that carbon's represented right here, there are no hydrogens connected to it. However, the other part of the cyclic structure, this carbon right here, there's three bonds connected to that point, meaning it would need to form, as you probably guessed, a fourth bond, and that bond would be to a hydrogen, and that is shown right here. You can see that there's that one hydrogen there. Now, if we go over to this carbon right here, you can see that there's only two bonds coming off of it. Now, since that's the case, that means there's got to be two more. And those two bonds would be the hydrogen atoms, and you can see that in the structure right here. This carbon has three bonds coming off of it. Don't worry about what this wedge means right now. We'll talk about that later. And therefore, it needs one more bond to a hydrogen, and that would be shown right here. The other carbon that you have in this molecule has four bonds coming off of it and has no need. So again, carbons and hydrogens aren't shown most of the time. The times where the hydrogen is shown, it's part of another functional group, such as this carboxylic acid region over here, or on these amine regions right here.